Phil Swift here.
I sawed this monitor in half.
Hey guys, welcome to the channel. In this video, we're going to be building a smart mirror. So it's kind of an involved project. You have to do some woodworking, you have to do electronics, you also have to do some coding. But overall, I think it'll turn out fine. I've never done one of these before, so I guess we'll be learning to get it. There is one snag to this project though. I kind of need a monitor, and monitors are usually within their own shell. So in order to make this as thin as possible, we've got to get rid of that shell. I cut right along the edge, so I'm gonna break it in two halves.
Fair enough.
Yeah, and it's not like I need this, like this can go. Well, this was the aftermath of a good day's work. Look at that. All garbage, right there. If you're not using a whiteboard for a coding section, you're doing it wrong. Let's get rid of all this. Now, I know most people hate coding, and like, fair enough, that's fine, but don't click off this section of the video because what they've done for this project is actually really cool. So I'm using a repository called Magic Mirror. How it works is it's actually implementation of a web page. So all I'm doing is putting a web page on my mirror, which is, it blows my mind. Cool. Someone has really thought this through. They've created a web server that runs on a mirror, and the whole thing is formatted like a web page. That's dead simple. That's stupidly simple, right? So this Magic Mirror is just a website on my mirror, which is freaking awesome. But then you can also do this thing with modules. The module we're using is Octo Mirror. And because of how it's implemented with a style sheet, you can actually put this module anywhere on the screen in a very specific location. So now you could put it in the top left corner. There's also a weather module.
Wonderful weather we're having.
You could put that wherever you want. You could put the news on here, whatever. But it's all associated with modules. It makes it really simple to configure. Nerd rant over. Let's get back to building the mirror. So welcome to my back porch / woodworking area. You can see I've got a table set up with all the tools that we need for this project. It's not the most stable thing that you would want. Got a Ryobi miter saw. That's not a miter saw. That is a circular saw. My bad. So the first thing we're going to want to do is cut out the back frame. So that is actually this schematic. So you have foot length of wood over here and about 2 foot lengths over here. So all we have to do is mark them up with a speed square and a tape measure, the whole like measure twice, cut once thing. And then we'll get cutting. I'm gesturing to a piece of wood that's on the floor. Cut that for the back frame, and then we can suit it up and make sure that it actually fits the monitor. Should I probably be using a jig for this? Yes. Am I going to? No. Well, that was stupid. Of course I needed a jig. That's how woodworking works. Okay, so I have this thought. We're gonna put in some corner brackets to the smart mirror, but they're not gonna be traditional brackets. So the brackets will be able to hold the frame at a right angle, right? That's a given. But I also want them to be able to adjust the tension on the LCD display. And the idea behind this is we can actually level out the LCD display in relationship to the acrylic sheet and to the mirror itself. Because the acrylic, if you have dimples and you have bends in it, you're actually gonna get a funhouse effect, which we're trying to avoid as much as we can. Because we're doing this on the cheap side, right? We haven't bought an actual piece of glass. We're using one-way acrylic. So what we're gonna do is we're gonna have to force them up right next to one another so we don't get that funhouse feeling. And it should work just fine. It's just like leveling out an Ender 3's build plate. There are just 4 screws in each of the corners. Well, 1 screw in each of the 4 corners. That's what I meant to say. We can just level it out. I guess it'll be fine like that.
You want to experience true level? Do you?
Yes?
Sick. Nice. That is so nice.
So now that we've done the housing, all we need to do is build the front frame. Now the front frame should be really easy. Here are the dimensions, right on the schematic, right on screen for you. It shouldn't be that hard to make. It's just 4 pieces of wood with these dimensions cut at 45-degree angles at each corner, and we're just gonna glue it up, go ahead and screw it to the housing, and then we should be good to go. So let's get cutting. Welcome guys, we're now on day 3 of this project. So the frame is all done, it looks really good, it's glued up really well overnight. The only issue is that when I left it to glue, I left paper on the corners. So now all we have to do is sand that down, give it a stain, and then we should be good to go. So let's get to that, yeah? We've got the housing, we've got the frame. The only thing we don't have is the mirror. Now, the mirror is the wrong size for this project, right? The 24 inch by 12 inch. That's not gonna fit our housing. So what we have to do is cut it down with a jigsaw. The thing is, acrylic is very hard to cut with a jigsaw. What I like to do is I like to layer it. So I like to put a piece of wood, a piece of acrylic, and then the wood on top again. That way, when I'm using my jigsaw, the acrylic doesn't come up and break. So if it breaks, you're done. It's an expensive part of the project and it cannot break. Otherwise, you're gonna have to buy another one. So let's go ahead and cut our acrylic. Let's get that done. And then we'll move on to final assembly. Hopefully, in the end, this thing looks like a mirror. Because if it doesn't, I'm going to be very sad. So let's see if this works. So the electronics for this project are kind of dead simple. It's just 2 power bucks, a Raspberry Pi, and a decent power supply. So the LCD display runs on 19 volts. So that isn't gonna power our Pi, and that isn't gonna power our LEDs, because our Pi runs on 5 volts, and our LEDs run on 12. So the 2 power bucks step it down to 5 and 12 respectively, and then once that happens, we just run the power accordingly. 1 power goes to the Raspberry Pi, 1 to the LED controller, and then we just run the main line all the way to the LCD display. That way everything is right as rain, tied up in a nice bow, and all the electronics work fine. And I ended up just shoving it in this 3D printed box that I made that houses everything and has a nice little vent port for the fan. And this electronics box is actually command stripped to the very back of the LCD display, just for ease. Yeah. I mean, it's the wrong way. But yeah. Ta-da! Oh, that is sick. That is so sick. Yes. So obviously I'm not gonna command strip this whole thing to the wall. Instead, I'm gonna use a French cleat. And it's really cool because it has 2 inclined planes and gravity's actually pushing them together and then forcing the mirror against the wall. So it should never move. We're gonna go ahead and cut one of those, install it, and then we should be right as rain to hang the thing. Let's hang her on the French cleat. Please don't break, please don't break, please don't break. Hey, perfectly balanced.
This whole thing should be.
Very nice, very nice. Let's plug her in. Yes. Yes, 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 yes. Hey, it's finished. It's safe to say that this thing looks cool, and I'm really excited to have it. It's better than having just like wood in the side of my apartment. Obviously, my apartment mates just love random wood just like scattered around the place. But it is finally done, and I'm excited with how this thing looks. And obviously, if you want to build one of these too, and if I couldn't like help with that, definitely check out my description. I put some Raspberry Pi videos and some woodworking videos there. Hopefully, those should help you with the process. But if this did help you, certainly consider subscribing, liking, commenting, whatever helps us beat the YouTube algorithm. I don't really care, just anything and everything. And I will catch you in the next video. So, see you guys later. Oh, you guys are still here? Cool, because there's something I forgot to tell you in the video. So, this is running the module Octomirror, right? And that means nothing to you all. Maybe it does, maybe it doesn't. But what it allows me to do is see all the data from all the instances of Octoprint that are running on my home network. So I can see all the print data from my 3D printers. And why is that cool? Well, I happen to have some 3D printers, and we're gonna be going over them in the next episode. All the upgrades I designed, all the light bar fixtures, all the firmware, everything. But yeah, video's over. Get out of here. I'll see you guys later.